Hello, this is Memphis Communiversity. Today we are doing our final graph response question topic. The difficulty is going to be 10. So what we've done is we've gone from difficulty 1 all the way up through difficulty 10. For the true response questions, we've taken a lot of areas. If you watch the series, we've done a lot of shapes of curves questions and things like that. But for now, we have one final one to do. This is going to be a pretty tricky one. It might not be that much harder than difficulty 9, probably not the hardest difficulty 10 video because we do this series for every single free response topic, but there will be questions that are going to be quite tricky. Basically, you take your standard question and then you just add a layer to it. So let's get started. Looks like we have a graph of F here. F is consists of line segments and also this quarter circle. The tricky thing about F is that while these points are 1, 2, 3, like normal, -1, -2, -3, and then this graph looks pretty normal with this quarter circle of radius 3. On this side, it's just a line, but the line doesn't end at a point that's given. It's just given at this constant A. So there's going to be questions that will involve A's, as we'll see. But let's get started. So our first question is find the average rate of change of F over the interval x1, x2. But of course, this is a little tricky. They don't give me the actual x1 and x2. What they're saying is you need to find x1 and x2 first, and those are going to be the inflection points of this function g, which is the integral of f. So if you've seen these free response questions before, usually keep in mind that this is a graph of f. Let's write that down. Usually they give you this information graph of this g function and the givens, but here it's in part A because only part A will use it. But remember, I like to apply the fundamental theorem of calculus, and I will immediately write g prime of x is equal to f of x. The derivative of an integral, of course, they sort of cancel out, so you have f of x here. If you wanted to, you could go a step further and you could write g double prime of x equals f prime of x, but I don't think that is necessary in this question. So let's do this. So first off, we're going to find the average rate of sum of f. Remember the average rate formula. The average rate of change is going to be the algebra slope of f over this interval right here. So let me write out the formula. In this case, it's going to be whatever x1 and x2 are, f of x dx. Sorry, this is the average rate formula with the integral. So remember that this is average rate because it's the average of f prime. But what we're going to do is we're going to take the antiderivative of this, and we're going to start off with algebra slope because we have f actually. So it'll be easy to find this value. So it's not x squared, sorry. It's x2, x2. So this is the formula for average rate. Just keep in mind that average rate is pretty tricky, again, because there's two formulas here. You can use either one. This is the average rate of f. You use this formula when you're given information about f prime. You use this formula when you're given information about f. And notice we're starting off with the graph of f, so it seems like we should be using this formula right here. But we do need to find the inflection points because the inflection points are what x2 and x1 are. So let's do that real quick. Well, the inflection points on a G graph, I can write the justification before I answer the question like normal. So G has an inflection point. I always want to refer to the graph of whatever it is. In this case, it's F. So I'm going to justify it as G prime equals F goes from increasing to decreasing or decreasing to increasing. So at two numbers because G prime equals F goes from increasing to decreasing or decreasing to increasing. Again, this question is harder because it's two parts. I want to find average rate of change, which is going to be this formula right here, but they don't say like find the average rate of change from 2 to 7 or something like that. So we would just put 7 and 2 here. We need to first find the numbers, and the numbers happen to be the inflection point. And G has an inflection point when G prime goes from increasing to decreasing or decreasing to increasing. In this case, it looks like it's going to be the number -6 and also 0. So it's going to be at -6 and 0. Keep in mind that at -6, it went from increasing to decreasing. And by it, I mean G prime equals F. And also at 0, it went from g prime equals f goes from decreasing to increasing. So looks like our numbers are going to be negative 6 and 0, so we're going to apply that there. We're going to find f of 0 minus f of negative 6 over, be careful, it's 0 minus negative 6. It's just algebra slope, but there is some sort of negative thing. We're going to go upstairs because I ran out of room. So it looks like it's going to be 6 on the top. I don't know what this is. And then f of 0 and f of negative 6, how are we going to find that from the graph? But it's going to be easy. Notice it's just the y values. So it's going to be, this point right here is 0, negative 3. So f of 0 is negative 3. And then f of negative 6, it's already labeled. It's 3. So we're going to get 3 here. So it looks like it's going to be negative 3 minus 3. Negative 3 minus 3. F of 0 minus f of negative 6. That's going to be negative 6. So the answer is actually just negative 1, which is not too bad. So let's box that. So again, why was this question harder than normal? Well, we are doing average rate of change, which isn't the hardest question, especially because we are given information about f, which means we're going to be using algebra slope. But we did have to find the points where we were doing algebra slope on. Those x coordinates were the inflection points, and inflection points, of course, are where g prime equals f goes from increasing to decreasing. So that's that question again. Not too bad, not actually harder than most questions. It just added a second step, or actually added a first step, where we had to find these points before we did average rate. So it sort of combined a shapes and curves question with an average rate question. So you can see why this free response level is going to be number 10. The questions are pretty tricky, but we were still able to sort of achieve what we wanted to achieve. We answered the question because we just slowly worked through the question and just saw what we needed. So before we answer the second question, let me just go over my normal shapes and curves rules because they're so important. So where's g increasing in this question? Well, again, g prime equals f. So if you want, you can look at our little cheat sheet we made a while ago. So g is increasing when g prime equals f is positive, and then so on with all these other rules. So I'm just going to answer them quickly for this question because I love to do that. G is increasing from here to here because g prime equals f is positive. G is decreasing from, it looks like, negative 3 to a because g prime equals f is negative. G is concave up from negative 8 to negative 6 because g prime equals f is increasing. Same thing from 0 to a. Finally, g prime equals, g is concave down between negative 6 and 0, it looks like, because g prime equals f goes, it is decreasing the entire time. It's literally going down. This point right here is a local max of g because g prime equals f goes from positive to negative. And finally, these were the inflection points. There are no relative min because there's no places where g prime equals f goes from negative to positive. So again, I'm just using these rules. Hopefully by this level of difficulty, number 10, if you've watched our videos, you are very accustomed to these rules. You want to see these questions on the AP exam, increasing, decreasing, concave up or down. You're no longer confused about how g increasing and g prime equals f has increasing. They're just two totally different rules. So hopefully you're good with that. So now let's do this question. It says, find the value of c for which the average value of f over the interval negative 8x to c is 2. So similarly to this question right here, average value is this formula. So instead of doing average rate, so we would put f prime in here. Now we're going to do average value here. I wasn't super precise. I should have written x2 and x1 because in these two the coordinates were x2 and x1. But let's move on. So average value over this interval, it's going to be 1 over c minus 8. Again, we're doing the formula 1 over b minus a integral of a to b of f of x. But of course, I don't want to use the letter a because there's an a right here. So it's going to be negative 8 to c of f of x. So again, the average of anything is 1 over b minus a, or the endpoints. And then what do you put in the integrand? You always put whatever you're taking the average of. So in this case, it was f. When we were finding average rate of f, that's the same thing as average of f prime. So that's why we put f prime in that integral. So in this case, we have to find the integral from negative 8 to c. So it looks like what we're going to have to do is we are going to have to find the area from negative 8 to a, not c. Let's use a. Sorry about that. I forgot that I changed my letters to a. So here A is this point. Not the best preparation, but hopefully you all understand that. So again, I'm going to find the area from -8 to A for this guy right here, and then I'm going to divide by 1 over A plus 8. And I'm not going to, this answer will be in terms of A, so what I'm going to do is I'm going to set this equal to 2 in the end. So let's do that. Let's find the area here. So it's the area from -8 to A, so there's no need to negate the integral because A is a bigger number than -8. And so it looks like it's going to be this triangle right here, this triangle right here, this triangle right here. This is actually going to be a negative triangle. We can split it up because it has some weird A thing. And this quarter circle. So let's find the area of this triangle first. It's going to be 1, 2, 3, 1, 2. So it's going to be 3 times 2 divided by 2. And that's just 3. So I'm finding the area, of course. So that's just going to be 3 here. That was the area of this triangle. 2 times 3, base times height, divided by 2. Then for this quarter circle, looks like it has radius 3. That's what it says. It has radius 3. So a quarter circle, the area of a circle is pi r squared. So the area of a quarter circle is pi r squared divided by 4. So it's going to be 9 pi over 4 because the radius is 3 and 3 squared is 4. Then I'm going to take this entire triangle. I'm going to do it separately, actually. I'm going to break it up from this triangle and then have this triangle as well because I want to split up my A. You could find the entire triangle if you wanted to, but I'm not going to do that. So this triangle looks like it's 1, 2, 3, 1, 2, 3. So it's 3 times 3 divided by 2. But because it's under the x-axis, it's negative area. So it's going to be 9 halves. And then finally, let's find the area of this one. A little bit tricky because there's some sort of A business, but we're still going to do base times height. It's going to be base is A, height is -3, so it's negative area. So it's going to be -3A over 2. So minus 3A over 2. And we're going to set this all equal to 2. Again, we're finding the average value of F over A, -8 to A. So we set up this formula. This formula, because we have a graph of F presented to us, right here. The integral of F is the area. So if you wanted to, you could write 1 over A plus 8 times the area between -8 and A. Finally, we just took the area slowly. This was an area of a triangle, quarter circle, the area of a negative triangle, and the area of another triangle with A in it. So now we just solve this little guy. We're just going to use algebra steps. I'm going to bring this A plus 8 to the other side. So it's going to be 2A plus 16. Because again, I'm multiplying the A plus 8 and I'm going to distribute that too. Finally, 3 minus 9 halves. Let's combine that. That's 6 halves minus 9 halves. So that's -3 halves. Plus 9 pi over 4. And then it looks like we're going to have a -3 over A over 2. So we have to solve this equation. It's going to be a little bit tricky, but it's probably the easiest part of the question, actually. So one thing is I don't like these fractions, so I can multiply everything by 4, and I'm going to do that. So it looks like we're going to get 9 pi right here. When we multiply this by 4, it'll be -6A. And then when we multiply this by 4, the 4 and the 2 will cancel, so it'll be -6. And then we're going to find the area of, we're going to multiply this by 4, so that's going to be 8A. And then 16 times 4 is 32 plus 2, which is 64. And now I'm going to try to solve this equation. It looks like I'm almost done, actually. Just taking this A to the other side, I'm going to get 14A. So I brought this over, and then I'm going to bring this one over. So it's going to be -6 plus -6 minus 64 plus 9 pi, and we are almost done. So let's just simplify this. -6 minus 64, well, that's -70. So we're going to get -70 plus 9 pi over 14 because we're dividing by 14 in the end. If you wanted to, you could break up this fraction. You're allowed to split numerators, and 14 does go into 70 actually pretty nice. So let's actually do that. Because 70 divided by 7 is 10, so 70 divided by 14 will be 5. So the final answer that we're going to write, again, this is perfectly valid, but the final answer we're going to write is -5 plus 9 pi over 14, and that's going to be our answer. So this, again, was a pretty difficult question, mainly because a lot of students have trouble when you have constants in the question and you're trying to solve for the constants, but this is a normal average value question. Average value of F being 1 over B minus A, or 1 over the endpoints of the integral from f of x dx over the length of that interval. So in this case, it's a -8 to a, so it's a minus -8. We didn't plug in 2, we set it equal to 2. And then to find this integral is the area under this curve. So we slowly found the area under this curve. We just added up and subtracted off the area of these shapes here. And then we just solved for a plus 8, brought it over, and then solved for a in the end. And that's how we did the question. So again, while there's some sort of tweaks to these questions because it is a pretty difficult level, difficulty number 10, it's still not too bad. We just stick to our guns. We know what we know. We set up the questions as if normal, and then we just proceed throughout the question, even if the computation's a little bit weird. So let's do the same thing for this question. So this one looks like it's going to be one of the easier level questions. All we're doing is we're just taking a derivative. So let's just start taking the derivative, h prime of 8, and we're going to plug in 8. So it looks like it's going to be h prime of x is equal to, well, this right here will be plus 2x in the end. And then for this, we do have to apply the chain rule, of course, because there's an inside function, x over 4. You can treat this as 1/4 x. So when we multiply by the chain rule, it'll be the derivative of this inside thing, which will be times 1/4. So let's do that. So it's going to be f prime of x over 4. And then you need to multiply by the derivative of the inside function, which again is 1/4. Then we're going to plug in 8, which won't be too bad. So let's do that. So it's going to be f prime of 2 inside here because it's 8 over 4 times 1/4. And then we're going to write 2 plus 8 because we plugged in 8 for x as well. So this is going to be plus 16 at the end. And then what we need to do is we need to find f prime of 2. So it says in the question that a is bigger than 2. So 2 is somewhere over here basically. And what we need to know is what's the slope of this line, because that's what will be the f prime value. But we can find the slope of this line pretty easily, even if we have this a thing, because notice this is the point a comma 0, and this is the point 0 comma -3. So we can just do y2 minus y1 over x2 minus x1 with these points. So let me list them out again. 0, -3, a, 0. The reason we're trying to find this is we're trying to find f prime of 2, and f prime's values are the slopes of these graphs. It's also g double prime, if you remember. So we're doing slope here, so it's going to be -3 minus 0, y2 minus y1 over x2 minus x1. So you're just going to get -3 over -a. Let's write that as 3 over a, of course. So we're going to place 3 over a with f prime of 2 times, that's an a, not a 2, times 1/4. And then it's going to be, of course, 3 over 4a plus 16. This is the answer. Not a bad question. This was probably the easier question. This was just taking a derivative. Just two small things in this question. Remember, when you take the derivative, of course, you have to employ chain rule. Be wary of that when you take any derivative on the AP exam. Secondly, to find the derivative, it was the slope of this graph. And if you notice, even though we don't know where 2 is, the slope of this entire line segment is consistent throughout the line segment. So I didn't need to find the slope of this line using the point 2 comma something. I could have used the slopes between the 2 points that were already given. So the slope at this point is the same as slope as this point, as well as this point. So we just found the slope of the entire line segment. That was my derivative, and I just replaced that with that. So not too bad of a question, just sort of the relationship between derivatives and functions with this graph, including the chain rule. So this last question actually isn't a shapes of curve question. So perhaps if you're watching this video sort of in sequential order of your calculus classes, you probably haven't come up to this topic. But theoretically, we have a graph here. And when you have graphs, it's possible to, of course, have area and volume questions. So I'm going to just throw in a random area and volume question at the very end of this video series, difficulty number 10. We might as well go out with a bang. So in this case, we have a region here. Before we start, just as a reminder, we do this difficulty 1 through 10 series for every single free response question topic. So if you want to practice our area and volume questions, that will be, we already have those videos up on our channel where we go from difficulty number 1 through 10 for area and volumes. But for this case, nice little preview if you've never seen it, or a little bit of a review if you have. So we have this region R. So it's going to be like this. We have, remember that we're doing cross sections instead of revolutions. So what's important with a cross section is always what axis it's perpendicular to. In this case, it is the x-axis, which is great because we don't have to do much sort of things involved. We don't have to manipulate the function, for example. And then the shape is always important. So it's going to be a rectangle. So how this works is because it's perpendicular to the x-axis, I like to draw this little sort of sliver, I guess. Basically, this represents one of the cross sections that is coming out of the page. So you can imagine that basically there'll be a rectangle of this where the base is this long and it'll be going up. There'll be a rectangle at this little sliver. There'll be a rectangle at this little sliver. You make the slivers as thin as possible and eventually you'll find volume. So again, check out our videos on cross sections if this confuses you. But everything is going to be dx's, so the length of the base of this is going to be top minus bottom, meaning the top function, which is just the x-axis, minus bottom, which is going to be this line. So what I like to do is, for these cross-section questions, I like to draw the shape. In this case, it is going to be a rectangle. The base of this rectangle is the most important side of this rectangle, in my opinion, because imagine if this is glued to, for example, this. So you cut this out. You like prop it up so it's 3D, and then this base is glued to this little strip or sort of sliver. And again, we want to be always integrating the area of the shape. That's how volumes work, because if you stack up a bunch of areas, you're eventually going to get volume. So we need to know the area of the shape, but once we know the base, we'll know the area of the shape, and the base is going to be top minus bottom. What I want to do is I need to write f of x as a function here. But it won't be too difficult of a function because it's just a line, as you can tell. Keep in mind, we already found the slope of this line. The slope is going to be 3 over a, so we can write 3 over a x. And then we need the y-intercept, and the y-intercept is going to be negative 3. So this is going to be the slope, the equation, sorry, of this line for f from 0 to a. So now we're going to do the sort of how long is the base of the shape. It's always top minus bottom, so it's going to be the x-axis, which is 0, minus this function right here. So it's going to be 0 minus 3 over a x minus 3. If you want, you can simplify this. The 3's will cancel, so it'll be, the negatives will cancel, sorry, so it'll be 3 minus 3 over a x. Basically, I'm distributing the negative. So again, this guy right here, the length of this is top minus bottom. What is the top of this sliver literally touching? What is the bottom literally touching? Top, the x-axis, bottom, the line here. Then we need to find the area of the shape. Of course, this is a rectangle, so the area of the shape is base times height. We needed the height. We only have the base, but it says the height is 5 times the base. That's great. So the height's going to be 5 times this number, or this function. So we're ready to go to set up the answer. So let's just write the answer in this little box here. So you always put the area of the shape, in this case it's a rectangle, inside the integral. It's the integrand, so it's going to be base times height. So I'm going to write it as 3 minus 3 over 8x. We'll write it in fancy notation. Obviously, when you multiply this by this, you're going to get base times height squared. And then we'll just have a 5 in the front because there's this 5. So again, this right here is base times height. Then you do have to choose coordinates, but the coordinates are the x-coordinates of this region. Notice it starts at 0 and goes to a. So 0 to a. And that is my answer for this pretty tricky volume by cross-section question, especially if you've never seen it before. But this is how volume by cross-section works. If it's perpendicular to the x-axis, that's great. You do top minus bottom. You'll see in those video series, if you watch those area and volume questions, where if it's perpendicular to the y-axis, you need to change everything to be in terms of y's, and then you do right minus left instead. But for now, we're doing top minus bottom. What's important about top minus bottom, it's always the base of this shape. In this case, we have the shape rectangle. We could have had semicircle. We could have had just a variety of things. But in this case, we had rectangles. So the base of the shape is going to be this, top minus bottom of this strip, because that's where the base will eventually lie. Then we need to determine height, but height, which is 5 times that according to the givens. And then finally, you're always integrating the area of the shape. So this integral right here is base times height. here 3 minus 3ax times 3 minus 3ax times 5, base times height. And then you choose coordinates based off what are the x coordinates in the region. In this case, r is only this guy right here because it was in the second quadrant. So it's going to be 0 to a. R was only in the second quadrant. We also didn't have to evaluate this integral. Perhaps we should have, because this integral actually isn't too terrible. Let's just verbally state how we would do this integral. You can expand it if you want to, or you can just do the power rule. So that's this integral, that's this question. Probably not really relevant for your sort of graph free response questions because they don't usually combine area and volumes, but it is a potential. So that's why we like to include it as a challenge and as fun. But that actually concludes our graph free response questions. Let me conclude what we did in this free response question and then just add a little bit of an outro. So the first question was average rate of change. We used this formula because we did algebra slope on F. Unfortunately, we didn't have the points already, but we easily found them because they were the inflection points, and we went over the rules to find inflection points. Then we found this average formula right here. We wanted to find the average value of F. We did 1 over b minus a, or 1 over the endpoints, the length of the interval. We set it equal to 2. And then to find this integral, we found the areas where positive area was positive, negative area below the graph was, of course, negative. Then we solve for a. Then we had a pretty easy derivative question, actually. It just required the chain rule. And then when we wanted this f prime 2 value, because this graph was of f, that was slope. And then finally, we did this cross-section question that we referred to. We saw is perpendicular to the x-axis, meaning all my answers have x's in it. Then we drew our cross-section. Base was top minus bottom, so it was the 0, the x-axis minus this function. We found the equation of this function because it was just a line with 3 over a slope and then minus 3 y-intercept. And then we integrated the area of the shape, which is base times height. So that's the conclusion of this video series. Hopefully this entire video series has been helpful for you. Again, these graph free response questions appear on every single AP exam that has ever been written. Keep in mind that these rules are always the most important rules. You want to be able to get these rules because in a more standard free response question, not like this difficulty number 10 video, but in a more standard level, you would know that some of these rules probably take up 4 to 5 points on the AP exam out of 9 for this particular free response question. So you want to know the 4 main things. You want to know increasing, decreasing, min, max, local min or max, G concave up or down, G inflection point. Those are the 4 main things. You also want to be careful with areas and things like that, where area beneath the curve is negative. We didn't actually find some areas in question 1, but for example, if we wanted to find G values and we plugged in, for example, -8, remember that you have to negate the integral. We saw a lot of those at the beginning of this video series, where instead of finding the area from -3 to -8, for example, because when you flip the integral, you're actually going to be finding the area, and then you're just going to write a negative in front because you had to negate the integral. So questions like that you want to be familiar with. You want to be familiar with fundamental theorem of calculus. F of x equals f of a plus integral a to b of f prime of x, and you usually find that integral of f prime of x with area. Again, you're being careful with area. But again, hopefully this video series has been useful for you. If you want, the most important ones are knowing how to do 1, 2, and 3 as an intro, but 4, 5, or 6 are probably around the difficulty of most AP exams. Our overview video, of course, will be helpful to watch as well as a nice little bit of a review. But again, thank you very much for your support and sort of following this series. We have series like this for every single free response question topic, both BC and AB. So for example, the one that I would check out maybe next are table free response questions. Eventually you'll come to these area and volume questions. You might come to differential equations, and then you might hit the BC stuff as well. But until then, thanks again for watching me. I hope I will see you in a later video series as we get better and better for the AP Calculus exam. Thanks again for watching.